proposed wiring solution for the exhaust fan is not legitimate. This configuration violates several national electrical code requirements and presents safety hazards. Firstly, it violates circuit integrity. The proposed wiring would create a mixed-use circuit, which is prohibited by the National Electrical Code. Circuit integrity requires that a circuit be dedicated to a specific purpose, for example, lighting or power. Secondly, it could overload the existing 240-volt circuit. Adding the exhaust fan to the 20-amp 240-volt circuit, which is already powering the dust collector, could cause an overload. The existing circuit is intended for the heavy load of the dust collector, and adding the fan might exceed the circuit's capacity. The proposed wiring creates significant safety concerns, including shock and fire hazards. Tapping into a single insulated wire from the 240 volts outlet to obtain 120 volts creates a potential shock hazard, especially if the insulation becomes damaged. Furthermore, overloading the circuit could lead to excessive heat buildup, increasing the risk of fire. The recommended solution is to install a separate dedicated 120-volt circuit for the exhaust fan. This circuit should be connected to a dedicated circuit breaker or fuse in the electrical panel and run directly to the fan location. This approach ensures proper circuit integrity, prevents overloads, and minimizes safety hazards. The National Electrical Code, or NEC, is a comprehensive set of standards for safe electrical installations. It's crucial to adhere to these standards to protect people and property from electrical hazards. One key principle is the concept of dedicated circuits. A dedicated circuit is designed to serve a specific purpose and load. For example, a lighting circuit should only power lights, and an appliance circuit should only power a specific appliance. Mixing different types of loads on a single circuit can lead to problems like voltage drops, overloading, and potential safety issues. The 240-volt circuit that powers the dust collector is designed to handle the high current draw of that motor. Adding another load, even a small exhaust fan, can push the circuit beyond its safe operating limits. This can cause the circuit breaker to trip frequently, and in more severe cases, it can overheat the wiring and create a fire hazard. Using a single wire from a 240-volt circuit to derive 120 volts introduces a significant safety risk. In a standard 240-volt circuit, there are two hot wires, each carrying 120 volts relative to neutral. The difference between the two hot wires is 240 volts. Tapping into only one of these hot wires and using a common neutral can create an unbalanced load and potentially overload the neutral conductor. Additionally, if the insulation on that single wire becomes damaged, it could expose a live 120 volts conductor, pose a serious shock hazard. The best and safest way to wire the exhaust fan is to run a new, dedicated 120 volt circuit from the electrical panel. This involves several steps. Firstly, identify an available circuit breaker slot in the electrical panel. If there isn't one, you may need to install a new subpanel to create more capacity. Secondly, choose the appropriate size circuit breaker for the fan's amperage rating. Typically, a 15 amp or 20 amp breaker will suffice for a small exhaust fan, but always check the fan specifications. Thirdly, run a new cable from the electrical panel to the location of the exhaust fan. This cable should contain 3 wires: a hot wire, a neutral wire, and a ground wire. Fourthly, connect the hot wire to the circuit breaker in the panel, the neutral wire to the neutral busbar, and the ground wire to the ground busbar. At the fan location, connect the wires to the fan's wiring compartment following the manufacturer's instructions. Be sure to use appropriate wiring methods and connectors for a secure and safe connection. The importance of proper grounding cannot be overstated. The ground wire provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker and quickly de-energizing the circuit in the event of a short circuit or other fault. This helps to prevent electrical shocks and fires. All electrical boxes, metal enclosures, and appliances should be properly grounded. Using the correct wire gauge is also essential for safety and performance. The wire gauge determines the amount of current that a wire can safely carry. Using a wire that is too small for the circuit's current draw can cause the wire to overheat and potentially start a fire. The National Electrical Code provides tables that specify the appropriate wire gauge for different amperage ratings and wiring configurations. Always consult these tables to ensure that you are using the correct size wire for your application. Another critical aspect of electrical safety is proper box fill. Electrical boxes are designed to safely contain wiring connections and protect them from damage. Overfilling an electrical box can create stress on the wires and connections, potentially leading to shorts, loose connections, and overheating. The National Electrical Code specifies the maximum number of wires, devices, and fittings that can be installed in an electrical box of a given size. Always follow these guidelines to ensure that your electrical boxes are not overfilled. In addition to the technical aspects of wiring, it's also crucial to follow safe work practices. Firstly, always turn off the power to the circuit before working on any electrical components. Use a voltage tester to verify that the circuit is de-energized. Secondly, wear appropriate personal protective equipment such as safety glasses and insulated gloves. Thirdly, never work on electrical systems when you are tired or distracted. Electrical work requires focus and attention to detail. Fourthly, if you are not comfortable working on electrical systems, hire a qualified electrician to do the work for you. Electricity is dangerous, and it's always better to err on the side of caution. Remember to consider local codes as well. While the National Electrical Code provides a comprehensive set of standards, local jurisdictions may have additional requirements or modifications. Always check with your local building department to ensure that your electrical installations comply with all applicable codes. This is particularly important for inspections and permits. Most electrical work requires a permit from the local building department. This ensures that the work is inspected by a qualified electrical inspector to verify that it meets code requirements. Obtaining a permit and passing inspection is essential for ensuring the safety and legality of your electrical installations. Here's a more detailed breakdown of the steps involved in installing a dedicated 120-volt circuit for the exhaust fan. Firstly, start by assessing the electrical panel. Determine if there is an available circuit breaker slot and sufficient capacity in the panel to handle the additional load. If the panel is full or lacks sufficient capacity, you may need to install a new subpanel. Secondly, select the appropriate circuit breaker. The circuit breaker should be sized according to the fan's amperage rating and the wire gauge used for the circuit. A 15 amp or 20 amp breaker is typically sufficient for a small exhaust fan. Thirdly, choose the correct wire gauge. The wire gauge should be sized according to the circuit's amperage rating and the length of the wire run. National Electrical Code Table 3.10.16 provides guidance on selecting the appropriate wire gauge. For a 15 amp circuit, 14 gauge wire is typically acceptable, while for a 20 amp circuit, 12 gauge wire is recommended. Fourthly, run the cable from the electrical panel to the fan location. Use appropriate wiring methods such as non-metallic sheath cable, also known as Romex, or conduit depending on the application and local code requirements. Secure the cable properly to prevent damage and ensure that it is protected from physical hazards. Fifthly, connect the wires to the circuit breaker in the electrical panel. Turn off the main power to the panel before working inside it. Connect the hot wire, typically black, to the circuit breaker terminal. Connect the neutral wire, typically white, to the neutral bus bar. Connect the ground wire, typically green or bare, to the ground bus bar. Sixthly, connect the wires to the fan's wiring compartment. Follow the manufacturer's instructions for making the connections. Use appropriate wire connectors, such as wire nuts or terminal blocks, to ensure secure and reliable connections. Seventhly, test the circuit. After completing the wiring, turn on the circuit breaker and use a voltage tester to verify that the fan is receiving power. Check the fan's operation to ensure that it is working properly. Here's an important note about GFCI protection. Ground fault circuit interrupters, or GFCIs, are devices that protect against electrical shock by monitoring the current flow in a circuit. If a ground fault is detected, the GFCI will quickly trip the circuit, cutting off the power and preventing a potentially lethal shock. The National Electrical Code requires GFCI protection for certain locations, such as bathrooms, kitchens, and outdoor areas. Consider installing a GFCI outlet or circuit breaker for the exhaust fan circuit, especially if the fan is located in a damp or wet environment. It is also important to consider the fan's location relative to other equipment. The exhaust fan should be located in a position that allows it to effectively remove dust and fumes from the shop area without interfering with other equipment or creating a safety hazard. It should be mounted securely and protected from physical damage. Additionally, consider the noise level of the exhaust fan. Some fans can be quite noisy, which can be a nuisance in a small shop. Choose a fan that is relatively quiet or consider installing sound dampening materials to reduce the noise level. Regular maintenance is essential for ensuring the safe and efficient operation of the exhaust fan. Check the fan regularly for any signs of damage or wear. Clean the fan blades and motor to remove dust and debris. Lubricate the motor bearings as needed. Replace the fan if it is damaged or not working properly. In summary, wiring an exhaust fan to an existing circuit is not a safe or code-compliant solution. The best and safest way to wire the fan is to run a new, dedicated 120-volt circuit from the electrical panel following all applicable National Electrical Code requirements and safe work practices. This will ensure that the fan operates safely and reliably, providing effective dust and fume removal for the woodworking shop. Remember that electrical work can be dangerous, and it's always best to err on the side of caution. If you are not comfortable working on electrical systems, hire a qualified electrician to do the work for you. In addition to the points already discussed, there are a few more considerations to keep in mind when wiring an exhaust fan in a woodworking shop. Firstly, consider the type of fan that is best suited for the application. There are many different types of exhaust fans available, each with its own advantages and disadvantages. Axial fans are commonly used for general ventilation, while centrifugal fans are better suited for applications that require higher static pressure, such as exhausting air through ductwork. Choose a fan that is appropriately sized for the shop area and the amount of dust and fumes that need to be removed. Secondly, consider the location of the fan in relation to the dust collector. Ideally, the fan should be located near the dust collector to maximize its effectiveness in removing dust and fumes. However, it should also be located in a position that does not interfere with the operation of the dust collector or create a safety hazard. Thirdly, consider the use of ductwork. Ductwork can be used to direct the airflow from the fan to specific areas of the shop or to exhaust the air outside of the building. If ductwork is used, it should be properly sized and installed to minimize airflow resistance and maximize the fan's performance. Fourthly, consider the use of a filter. A filter can be installed in the exhaust fan system to remove fine dust particles from the air before it is exhausted outside. This can help to improve air quality and prevent the spread of dust to other areas. Fifthly, consider the use of a speed control. A speed control can be used to adjust the fan's speed to match the needs of the shop. This can help to save energy and reduce noise levels when the fan is not needed at full speed. Finally, it's always a good idea to consult with a qualified electrician or HVAC professional to get advice on the best way to wire and install an exhaust fan in a woodworking shop. They can help to ensure that the installation is safe, code compliant, and effective in removing dust and fumes. This ensures that the 120-volt circuit has a neutral wire to return the current and the ground wire that protects the circuit in case of a short circuit.